we're going to talk about the idea of max and min for a function. And there's going to be two different types here. We are going to have local max and local min. And we're also going to have something called absolute max and min. Just in case you ever run across these terms, because they are definitely common out there, local is the same as relative, and absolute is the same as global. So depending on the words you may see out there, this is what we have. Now the idea is, if you look at your function and you ask, what is the lowest point on the graph anywhere? So in this case, the lowest absolute point right here, that is going to be your absolute minimum. So it's relatively easy to see that if you look at your whole graph, whatever the lowest one it is, that's going to be the absolute minimum. Similarly, an absolute max would be the highest point on your graph. Now this function here, because of the arrow, it's going to keep going up higher and higher and higher. And so what that means is there is going to be no absolute max. So I wanted to kind of point out that you may have a max or min, or you may have one but not the other, or you may have neither. It's really going to depend on the specific function here. The next thing we want to look for are things called local max and min. So if you look at this little point right here, it's the lowest in that area. It's just not the lowest anywhere overall. So we would call that a local min. Similarly, this point right here is another local min. And in fact, this one might be confusing here, but this point over here is also a local min because the absolute's also going to be lowest in its immediate area, so therefore it's also a local min. I know, it might be a little strange there. Similarly, we also have these 2 points here that are going to be local maxes. Even though there's no absolute max, there is, a peak or a highest point in a given area, and that's going to be your local max. Now there's a nice little theorem in math that tells us the following here. Local min and max will happen only at points where either the derivative is equal to 0 or the derivative is undefined. And these are called critical points. So when they ask you to find the critical points or the critical numbers, that just means take the derivative, find out any place where it's 0 as well as any point where it's undefined, and those x values are going to be your critical numbers. So here we have find the critical numbers for this function. We take our derivative, 3x squared minus, let's see, if I bring the 5 halves down, it's going to be 1. It's going to be x to the 3 halves here. So if I were to set this equal to 0, I would go ahead and get x to the 3 halves there. Maybe square both sides. 9x to the 4th equals x cubed. Make it 9x to the 4th minus x cubed is 0. Factor out x cubed, 9x minus 1. And we're going to get two values here. X is 0 and x is 1/9. So these will be your critical points. You'd also have to ask yourself whether f prime of x is undefined anywhere. And so we know what undefined is, like if you're dividing by 0 or things like that. Now there's no problems here, so therefore there's no more critical points. And then we just get two critical points, 0 and 1/9. Now, what if we want to use these critical points and actually find max and mins? Well, it turns out it's going to be a little easier to find absolute max and mins. We'll do that first here. And the following is true here. So an absolute max or min will only happen at either a critical point or an endpoint of the interval. And we're going to give you an interval every time so that we can use that here. Because if you have a graph that goes off to infinity, you won't have an absolute max. But if you force yourself to stop at some point by putting an interval there, then there will be an absolute max. And that's what we're always going to do here. So if you're given a problem like this, first thing, find the critical points. Take your derivative, 6x squared minus 30x plus 36. Set it equal to 0 here. And then we solve. We can just do a little bit of factoring. Minus 2 minus 3. So we're going to get two critical points. X is 2 and x is 3. We also are going to need to try the endpoints. X is 1 and 5. And we're going to plug all of those into our function. F of 1, f of 2, f of 3, and f of 5. Now they can be a little tedious here. Let's see. Plug in 1. That's going to be, what, 38 minus 15 is 23. I'm going to use my calculator for the next of them here. So 2 times 2 cubed minus 15 times 2 squared plus 36 times 2. I'm going to get 28 here. If I do the same thing, but now with 3 involved, I will get 27. And if I do the same thing with 5 involved, I get 55. And remember what absolute max and min are is the absolute highest value and the absolute lowest value. So that means 55 here. That means that point is going to give us the absolute max. And 23 is going to give us the absolute min. So whenever they ask you to find an absolute max or a min on an interval, you just take the derivative, set it equal to 0 or undefined, find your critical points, then throw in your endpoints, plug all of them into your function. Whatever the highest value you ever get is your absolute max, and whatever your lowest value you ever get is your absolute min.